Hello everyone, this is James. I'm the project sales manager from SINTRONES. The subject of this section is 5G connectivity and AI-enabled vehicles. Since 2009, SINTRONES has been focusing on in-vehicle computers design and manufacturing. With the advance of technology, the applications of in-vehicle computers are becoming diverse and complex. Especially 5G and AI has greatly changed the vehicle's design and raised the hardware requirement. In the next 15 minutes, I'm going to introduce how AI and 5G work in transportation field and share some SINTRONES solutions to demonstrate in-vehicle computers deployments. At the very first beginning, I would like to share the market trend and the forecast of AI and transportation-related field. The upper report shows global AI in transportation, including deep learning, computer vision, and natural language processing. Market value will reach $3.5 billion in 2023. From another report, we can learn global automotive AI market is expected to reach $8.8 billion by components, technology, and applications. For smart transportation, which includes railway or airway solutions, logistics service or technologies, it will reach $156 billion in 2025. We can see from the three different reports all indicate very positive growth in the next 3 to 5 years. To have a basic concept of how AI works in transportation, here I would like to go through some popular applications. The first one is passenger transportation. We already can see the technology in airport terminals or bus systems. The driverless buses use sensors, cameras, and a GPS to safely ferry passengers to their destinations, and AI is used to predict and plan the path and avoid accidents. The second one is intelligent traffic management. The system can recognize the physical and environmental conditions that can lead to heavier traffic flow and congestion. It can automatically suggest alternate routes to relieve any traffic that has been formed. As to fleet management, this is very common in logistics or public transportation. It applies GPS vehicle tracking, driving behavior analysis, fuel management, and the route planning. The system improves the efficiency and minimizes the operation cost. Another common application is driver assistance. It is intended to avoid collisions by using technologies to alert drivers for potential dangers or take over control of the vehicle to avoid accidents. Law enforcement. This can be found for overspeed or traffic rules breaking detection. Different from the past, no police are needed to stand on the intersections, but replaced by cameras and AI to capture violations. The last one is autonomous vehicles. This has been highly discussed for recent years, and later on, I will talk about this topic in details. We just went through the major AI applications in transportation. Next, I would like to share 4 SINTRONES solutions, which combines edge computing products with AI software to improve the car and the road safety. The first 3 applications are remote monitoring, advanced warning system, and driving distraction prevention. Lastly, I will explain how the 5G and the Internet of Vehicles work together in autonomous cars and what solutions SINTRONES can offer. Now, let's get started from the remote monitoring. Nowadays, most of the modern buses are equipped with surveillance system, but SINTRONES remote monitoring is a complete upgrade. This application is installed in Canada bus system. It adopts SINTRONES AirBox 5200. We utilize the 8 PoE ports to connect with 8 IP cameras to ensure internal or external space is completely covered to reduce the blind spots and improve the driving safety. Not only recording, but the system can also observe the driver's or passenger's behavior. If any suspect of violence is found, the control center will receive the notice and take prompt actions. To make sure there is no delay for the video streaming and the smooth communication with control center, we would need another feature, LTE module. Plus GPS positioning, we can realize fleet management and emergency notification. The backup battery can help the computer to keep operating even the vehicle loses power. This is essential to keep complete evidence and extend the time for sending SOS signals. The above is Sintron's solution for remote monitoring. The second application is the Singapore Bus Advanced Warning System. Firstly, I would like to show you the blind spots of large vehicles. As you can see, the red area shows huge blind spots at the two sides and the rear part of large vehicles. To improve the driver's vision, our partner installed lots of radars around the vehicle and adopts LiDAR to scan and map the surroundings. If objects are found within the surrounding area, the software will calculate the object's speed and the direction to predict its path and send alert to the driver. This application adopts Sintron ABUS 5000 series. The sufficient I/O are used to connect multiple radars, and the ABUS equips with dedicated GPU for timely scanning and image recognition to provide path prediction, reduce blind spots, and improve driving safety. The next application is driving distraction prevention. We can also tag this as technology law enforcement. I believe most of the drivers would use their cell phone from time to time while driving, especially when receiving someone's texting. We will involuntarily reach the phone and have a glance. However, even you think you just take 1 to 2 seconds to check the message, this behavior may cause serious accidents. Assume the driving speed is at 40 kilometers per hour. Using cell phone for 1 second will equals to blind driving for 11 meters and increase the risk for accidents. In Sydney, Australia, the government is targeting to stop drivers using cell phones. They work with system integrator to design a software installed on Sintron's ABUS 5200. To detect cell phone usage, the cameras are installed near the main roads and captured images are analyzed by AI. The system can recognize holding cell phone behavior and issue tickets to the car owners. Because of vehicle's high speed, the system needs to capture the image and recognize the behavior within seconds. Therefore, the computer requires advanced CPU and GPU to process the data. In addition, the patent-friendless design of ABUS overcomes the high-temperature environment in Sydney. During the 1-month trial period, the system has issued more than 11,000 tickets and reduced the accident rate. We already talked about the remote monitoring, advanced warning system, and the distraction prevention. The next application is the future of safe transportation, autonomous car. In this topic, we will talk about 5G and the Internet of Vehicles, V2X. But before we go any further, I would like to start from explaining the automation levels of autonomous cars. According to the Society of Automotive Engineers, the driving automation can be divided into 5 levels. From the level 1 to level 5, they are driver assistance, partial automation, conditional automation, high automation, and full automation. So far, for the legal vehicles on the road, even the advanced Tesla, the highest automation levels is only at level 2. That means most of the so-called auto-driving cars are still needing humans' intervention. In recent years, the major car manufacturers or software developers are committed in advance to automation level 3, level 4, or even level 5. The reason of the self-driving car upsurge not only led by the popularity of electric vehicles, but also count on the trending technologies V2X, AI, and 5G. Since we'll talk about V2X, there are 2 major technologies we need to mention. One is dedicated short-range communication. We can call it DSRC. The other one is cellular vehicle to everything, CV2X. Please take a look on the left column. DSRC was developed in 2004, and it is already a matured technology in US and European automotive market. However, due to its local network frequency band, DSRC is limited for internet connectivity. Back to CV2X, it started in 2018. No matter in the support speed, reacting time, transmission amount, or transmission range, the performance of CV2X is beyond DSRC. Most important of all, it is compatible with LTE and 5G, which enables the large amount of data transmission required in the practice of self-driving and not limited by distance and signal range. So, why self-driving cars require large amount of data transmission? To answer this question, we shall understand the two major applications in driverless car. First, onboard unit, OBU. This refers to the in-vehicle hardware. The purpose is to simulate the driver's vision and observe the changes of road conditions by integrating sensors, radars, cameras, and image recognition technology to predict the safe driving path. The other application is roadside unit, RSU. It refers to the device, equipment, or infrastructure on roadside. Instead of relying on the vehicle itself, RSU communicate with traffic signals, cameras near intersections, pedestrian sensors, or weather conditions, and exchange data with OBU. When the prediction data does not only come from the vehicle, but also from the roadside and surroundings, the safety of self-driving car will have breakthrough improvement. Regardless OBU or RSU, the communication and the data transmission is based on the high speed and the low latency network of C-V2X. With 5G's connectivity, the data source is mass and diverse, which can improve the prediction accuracy of autonomous driving and furtherly ensure the safety. We just introduced the two major applications in autonomous car, OBU and RSU. And from SINTRONES, what kind of solution we can offer to satisfy this edge computing demand? For OBU, onboard unit, since it's installed on vehicles, the system needs to perform the image recognition less than 1 second. Therefore, the hardware requires advanced CPU and GPU. ABOX 5210 is powered by Intel Generation 10's processor and NVIDIA Quadro RTX 3000. Patent-friendly design adapts to the vehicle high-temp working environment and prevents the CPU and the GPU from overheating. The most important feature is supporting 5G module, which is the key in the C-V2X and the practice of self-driving cars. As to RSU, SINTRONES' solution is EBOX 7000. It is powered by Intel Generation 9's processor and supports NVIDIA Deep Learning graphic card. It can equip with 5G modules as well. The highlighted feature is EBOX supports standard PCIe expansion. With this feature, EBOX can be extensively applied in roadside devices or infrastructure and not restricted by mobile device format. During my presentation, I mentioned two SINTRONES products, ABOX and EBOX. These are our popular models for edge AI computing. Here, I would like to give you an overview of these two rising stars. Beginning with ABOX. It supports up to Intel Generation 10's CPU, and it can work with NVIDIA Quadro RTX 3000 graphic card. All the essential functions of in-vehicle computers such as PoE, HDMI, dual SIM, and the 5G module, wide temperature, wide voltage, and the backup batteries are available on this unique product offering. For service industry, ABOX is ideal for autonomous cars and in-vehicle applications. Next, let's look at EBOX. It is powered by Intel Generation 8 to 9 CPU. And for deep learning application, EBOX can work with NVIDIA Tesla T4 graphic card. It also equips with the key features like PoE or 5G module. But the most important product highlight is the additional standard PCIe expansion. With the standard PCIe, EBOX is good for transportation management and smart manufacturing. At the beginning of my sharing, we already learned the growth and the trend of AI in transportation, and edge AI computing raises the hardware requirements of in-vehicle computers, especially needing high-performance CPU and GPU, plus 5G connectivity for fast and mass data transmission. From the product overview, SINTRONES has designed these features in our edge AI computing offering, and we are well prepared for the challenges from intelligent transportation and smart cities. The above is my presentation today. Thank you for your time and attention.